There's one more thing that I'm going to talk through about minerals before I start like breaking them out all over the place, and that's going to give you guys some basic terms about how, when we're identifying minerals, what we use to identify. There's some different physical properties to minerals that, by looking at them and kind of going through a mental checklist, you can narrow down and figure out what mineral you're working with. The first one is going to be the obvious. It's a lot of like, what's fun about geology, one of the things I always loved about geology is that so much of it is the basic senses. You know, you don't need to work on a theoretical level all the time because you've got the thing in front of you. I mean, sometimes you do. You have to, I'll show you guys at some point the print I have that's like, we don't know what's inside the earth. I am talking a lot before getting to the thing. Anyway, this is gonna be a multi-part video, I think. Anyway, first thing is color. Big determining factor. What color is the mineral? Sometimes it can play tricks on you. A lot of minerals can come in multiple colors. A really good example of that is quartz. Quartz is amethyst, which is purple. You got rose quartz. You've got smoky quartz. You've got regular like rock crystal quartz. None of them have magical powers depending on the color they are, no matter what anybody wants to tell you. We'll get into that and explanation of why those minerals are all different colors later. But color can tell you a lot right off the bat. The next thing is going to be luster. Luster is sort of related to color. It's the way that light reflects off of the rock. When you look at it, does it look like the way that a brick doesn't have luster? It doesn't reflect light back, right? Versus a window pane, it's going to have a different way that light reflects back. So when we talk about luster, we're talking about the play of light on the surface itself. A really good example is with the serpentinite we looked at the other day. Like how I was saying, it looks greasy, it looks oily. That is huge. That is a big identifier, and that's the luster. The luster is that it looks and also feels, but looks like it's got grease on it. And so that will tell you something. If you're looking at a gemstone, gemstones have what's called adamantine luster, which is this, it is what a gemstone looks like. So those are two. Next video, we'll go through some others. We're back. Video 2, talking about, I don't know why I'm mirroring everything with both my hands, talking about different physical and chemical properties of minerals that we can use to identify what a mineral is. So we've done color, we've done luster. Next up, we're gonna do hardness. Hardness is basically how easily it scratches. So something really soft, think of like a bar of soap. You can scratch that with your fingernail. Different minerals, because of the way that the bonds are between the different elements, things like that, the crystal structure, different minerals have different hardnesses. So what you can do, there's actually a scale that exists with some markers. This mineral is a 1, this mineral is a 2, and it goes 1 through 10. 1 being the softest, which is talc. Talc is extremely soft, like talcum powder. And 10 being a diamond. The only thing that you can scratch a diamond with is another diamond. So a lot of the time, one of the ways to identify a mineral is by testing its hardness. First thing that you get drilled into your head when you're in school for geology, when you're doing a basic mineralogy course, you memorize the hardness scale. Because you can use those markers to figure out what the hardness of your mineral is. Whether or not it is one of the marker minerals, it will tell you something about it. So you can use other minerals to scratch each other. You use your fingernail, you can use a copper penny, it has a certain hardness. A iron nail will have a certain hardness. There's just different things. One of the big ones, glass. Glass has a certain hardness. So you use all these different things to determine, does it scratch this? Is it scratched by this? If it's scratched by the object, it's softer than that object. If it scratches that object, it's harder than that object. So we use that, that's a big determining factor. I'm not gonna talk a lot about that when I go through my minerals because I don't need to use that. I'm mostly gonna talk about things like color and luster and some other stuff we're gonna get into in the next video. We're gonna talk about streak. Basically, when you take a mineral and you'll have like a little ceramic plate, and if you drag that mineral along the ceramic plate, it leaves behind a streak of color. Sometimes that matches, like you'll have a black rock that will leave behind a black mineral that will leave behind a black streak. Sometimes it doesn't. A really good identifier for the mineral hematite, it's a blackish, grayish, sparkly rock, metallic looking rock. it will actually leave behind a red streak. So that tells you really quickly that's hematite. It's a great way to determine that it's hematite versus magnetite, especially if you're in a situation where you don't have a magnet, which would be the good way to determine if magnetite is magnetite. It's magnetic. It can just be a good differentiator, especially when you're trying to tell between a few different minerals that look alike but might have different streaks. So next up is density. Density is essentially like how heavy the item is for its size. Density is really about how much water anyway, essentially the easiest way to say it is it's heavier than you would expect it to be at that size. Something is not dense if it's much lighter than you'd expect it to be at that size. A good example, a pillow. Pillow is not dense. Pillow is very, very light for its size. If you had something the same size filled with a bunch of iron, it would be very dense. It would be more dense than a pillow. Likewise, when you're talking about minerals, sometimes you have minerals that are very, very, feel like nothing. Talc, again, I mentioned that before. Good example of it. It's very light, very lightweight. It is not dense. And then by contrast, you have something like an iron or hematite or a magnetite, which for its size, you pick it up and you feel it. And that will, right off the bat, tell you something very valuable. Another good example, galena. Galena is it's an iron mineral that is just, you feel it immediately. It's basically what like weights are made out of. Your hand just drops. So being able to tell, is this a really dense mineral, will tell you something. We've done color, luster, streak, hardness, density. I think that's all we've done, yeah. Now we're gonna talk about something called cleavage. Cleavage, so we're getting onto an atomic level here for a second. Minerals are made of compounds. Compounds are made of elements that have been bound together. When elements bind together, they share atoms. Those bonds can have different degrees of strength. There's some very strong kinds of bonds, a covalent bond where they're sharing where they're basically they're sharing electrons. There's something very weak. It's called a van der Waals bond. And those are going to be extremely weak bonds that are easy to break. The stronger the bond, the harder to break. Pretty straightforward. Here's where cleavage comes into play. When you have these crystal structures, there are certain places where the bond is going to be weaker than others. When you can hit along that bond, you're actually going to shear off a chunk of that. You're going to shear that rock in half, or that mineral in half. I don't know why I keep using rock and mineral interchangeably. You're going to shear it in half, and you're going to get a flat plane out of it. But it might not be at a 90-degree angle. There are different angles that you can get it at. You can get it at a 120-degree, 60-degree angle, so like that-ish. You can get it at a 45-degree angle. Nah. You can get it at a 90-degree angle. Different ways to do it. Depending on what mineral you're working with, different minerals have different cleavage angles. Great example that you can see in your house is if you look really closely at some table salt. Table salt is halite. Halite basically makes tiny cubes. So if you take some salt in a grinder, if you've got like a salt lamp and you want to hit it with a hammer, you will actually see that it starts to cube into 90-degree pieces, and it will be very small, and it will happen on very small levels. So that's cleavage. Now we're going to talk about crystal habit. You've definitely seen those like really gorgeous samples of like a quartz that has its like pointy top, and then it's like shaped, and then it's long and cylindrical. That is crystal habit. If you are allowing this crystal to grow in the perfect circumstances, unbothered, lots of ample space, nothing else affecting it, how's it going to come out looking? Certain minerals are going to do the same thing every time. Some minerals are going to do little different things, but it can be a really good descriptor. It's not just about the one big crystal. You can also look at a mineral that has, it might have different textures. So the crystal habit can inform the texture of the mineral itself. So you might have a mineral that looks like a bunch of needles put together. A really good example is asbestos. So the mineral that makes serpentine, it's in the asbestos family. If you've ever seen asbestos, it looks like a bunch of like fibers. It's a fibrous texture. And crystal habit to discuss the shape of the mineral itself. So this is the last thing, tenacity. How flexible is it? Is it very brittle? If you bend it, does it snap in half immediately? Something like gold is actually really, it's malleable is the tenacity. You can actually like basically stick your fingernail in it and it will morph around it. It's very malleable. So those are the physical properties. There's other things that we can use. Is it like special properties? Is it magnetic? There's also chemical properties. So like that's a fun one to do because you take some hydrochloric acid and you put it on anything that has calcium in it, like calcite, and it will bubble. It's really fun. Anyway, halite, it's salty. You lick it, it's salty. Sometimes you want to lick minerals. It's what happens. You'll just be able to tell whether or not you've already put hydrochloric acid on it. So yeah, so geology is the only science where you're encouraged to lick things, which, you know, that's why geology is cool. We lick things.